In this video, I want to begin our discussion of model building. Model building is a step in our regression analysis where we're trying to figure out the best way to introduce the independent variables, we'll call them the x's, into a model to try to predict y as accurately as possible. Remember, our whole goal in all this regression analysis is we're trying to predict the dependent variable y. We want to know what is that value and how can I accurately learn about that value. And we've introduced a whole bunch of independent variables to the mix. Now, in subsequent videos or lectures, we've talked about the different model terms, the different ways that we can introduce independent variables to the model. And we've differentiated between the idea of a model variable, which would be one of the characteristics of the experimental unit we're interested in, and a model term. And I use the word model term to talk about the way that that model variable is introduced. As an example, let's talk about houses. Let's say we want to predict the sales price of a house. Well, most of us would say there's a bunch of different variables that'll help to do that. We can look at the size of the house. That obviously should have something to do with the price. The bigger the house, the more it should sell for. And so we'll introduce a quantitative variable called size, or size of the house, and we measure it in square feet, and we'll call that x1. That's a variable. Now, the way that we use x1 may depend upon our situation. We may think there's a linear relationship between y and x1, between sales price and size. In fact, most of us would say as size goes up, price should go up. So we're going to use a linear relationship. Well, that would be the term x1 in our model. So we'll put a beta attached to an x1 in the model. But someone else may say, well, maybe there's a curvilinear relationship. Maybe as x1 gets bigger, y goes up, but it's not in a linear fashion. Maybe there's some kind of curve attached to it. And so they'd say, let's include an x1 squared term. And so I'll talk about x1 being the variable and x1 squared being two different terms that use that variable. Hopefully that makes sense. Now we can introduce other ideas like the location of the property. In real estate, what do folks say? How do you determine the price? It's location, location, location. You can change the size, you can change the condition, you can change a lot of things about a house, but you cannot change its location. And so a location variable, well, that's a qualitative variable. Now we can talk about an interaction idea. Is the price-size relationship, and in real estate we talk about the price per square foot, is that relationship the same for this location as it is for that location? And so we have these interaction ideas, because if you say they are the same, then you don't need to interact those terms. If you say they're not the same, then you do. And again, we've talked about these model terms in subsequent or in earlier lectures, previous, not subsequent, previous lectures. But now we want to put it all together. And so what we're going to do, what our model building kind of philosophy says, we want to allow for any of these relationships. Most of the time, I'm not sure. I might have some ideas, but I don't know what the relationship between y and the x's is. And so I want to allow for a lot of different relationships. And so we're going to begin our model building with what's called the complete second order model. Okay, and the complete second order model includes everything. We've talked about quadratics. Yeah, throw them in there. We don't know if we have a linear or a curvilinear or a quadratic model. Let's put them both in and see what we need. Interaction, no interaction? I don't know. Well, let's allow for interaction. We have an easy way to check to see if we need it. Qualitative variables? Sure, throw them in. Quantitative variables? Absolutely. And so the complete second order model says, let's go ahead and look at everything. Now this phrase, second order right here, that's the key. We're going to talk about the order of a model term. And the way I'm going to talk about is the order of the model term is determined by the number of quantitative variables that are in that term. Now what's that mean? If I have an x1 term, and say x1 is size of the house, that's a first order term. x1 squared would be a second order term. x1 cubed, hopefully you're seeing where I'm going here, that's a third order term, right? So the order is dictated by the number of quantitative terms. Now where it gets tricky is when you're working with qualitative variables. As we've seen before, qualitative variables are represented with dummy variables. Let's say we have two locations. We'll use a qualitative variable x2, and we'll say x2 is equal to 0 if one of those locations, and it's equal to 1 if the other location. We use 0, 1 dummy variables. And again, we've talked about this. I'm just trying to put it all together here. But here's the reality. If you have a qualitative dummy variable, a 0, 1 dummy, representing two different levels of a categorical or a qualitative variable, it's not quantitative. It doesn't add to the order. So if I have an x1 term that's quantitative, that's a first order term. If I have an x2 term that's qualitative, when we talk about the interaction between them, the x1, x2 term, that's a first order term as well. x1 squared, I'm just going to put it in here, that's a second order term. So is that x1 squared, x2. And so what we want to try to do is look at all, what we talk about second order model, we want to look at all second order terms, all first order terms, and then really, if you think about it, we want to also include what I'll call a zero order term. x2 would be considered a zero. There's no quantitative variable there. And so we want to put that all together. And so there's really two different ways of doing this. There's called the hunt and peck method, where you just start building the model and say, well, let's put in x1 and let's put in x2 and let's put in this and let's put in that. And that's one way of finding the complete second order model, but there's a better way. And that's what I want to talk about here. We're going to use these 3 steps. If you follow these 3 steps, you're guaranteed to get the right starting point. And this is where you start your model building. That's all I want to talk about in this video. Where we start with our complete second order model. We start with all the quantitative terms in the model. And so what I want to do is really what we're doing is saying, what variables are we considering? You start with that, what variables? And then you kind of partition them. You say, the thing we're trying to predict, that's y. Put that over here on the shelf. So that's out of the equation right now. That's the y. That's the e of y. That's the thing that's on the left-hand side of the equal sign in the equations that we build. E of y is equal to, and now we're talking about, well, what are we going to put in the right-hand side? Well, there's beta naught, and there's beta 1 x1, and this says start with the quantitative variables. So those independent variables that you're considering, the size of the house, the age of the house, the size of the lot that you're building on, those are the quantitative variables. And then there's the qualitative, the location. Is it in 0 or 1? Those 2 locations we talked about. Does it have a swimming pool? Yes, it does. 0. No, it doesn't. 1, or the other way around. Does it have a security system? Is it in a gated neighborhood? Is it on a golf course? Is there some kind of waterfront view? All the different variables that you can think of that might have something to do with predicting the price of the house, they would be the qualitative variables. In step 1, we just look at the quantitatives, and we add in all first and second order terms, all the first and second order variations. So let's get away from what we talked about up here, okay? Let's say we have 3 quantitative variables, and you're going to see how quickly these models get big. Let's say we have 3 quantitative variables when I'm having this conversation down here with number 1. We're going to put in, let's call them x1, x2, and x3. We're going to put in all the linear versions of it. So we'll put in an x1 term, we'll put in an x2, we'll put in an x3. We'll put in the squareds, x1 squared, x2 squared, x3 squared. And then we can interact them. x1 can interact with x2. That's a second order term. x1, x3, second order. x2, x3, second order. And when you start doing this, it's tempting to go crazy and say, well, let's put in x1, x2, x3. Let's put in x1 squared, x2 squared, x3 squared. Let's just go crazy. And this is where the order gets us. Most things have either straight or curvilinears, linear or curvilinear relationships, and so we stop at second order. We'll put in an x1, x2 interaction term. We won't put in an x1, x2, x3 interaction term, because that would be third order. And so the second order is kind of our ceiling. That's what we stop at. So in step 1, and I'm ripping off all these terms, and you're probably head spinning a little bit, and what I'm going to say is, relax. We're going to look at a lot of examples. We'll see some examples in this video, and then we'll go and take a look at some beyond this. So start with your quantitative terms. That's the bottom line. Second step is now work with those dummy variables, those qualitative variables. Does it have a pool? Yes or no? Which location is it in? Does it have a security system? Those are called the qualitative terms, and they are 0 order terms. So like when I talked up here about the x2 term, we said it was qualitative. That's got 0 order. So let's say if x1, x2, and x3 were all quantitative here, let's talk about 4, 5, and 6 being qualitative here. And again, we've mentioned the qualitative terms before, so you should be familiar with them. Hopefully you've seen that information. But now let's say I have x4, x5, and x6. Well, I can put x4 in. I can put x5 in. I can put x6 in. They're all 0 order. I can do x4, x5. I can do x4, x6. I can do x5, x6. They're still 0 order. I can even do x4, x5, x6, and that's still considered a 0 order term. And so what you tend to find is that the qualitative variables, the number of qualitative variables you have, tend to make the models get very big very quickly because of all the interactions that can occur. So that's really what you need to do is take a look at your independent variables, kind of make a list. Say on this side we're going to put the quantitatives. In step one, you work with those. You put in first and second order variations of them. And then the second step, you look at the other side of the line and say, well, here are our qualitative. And remember, these are just the independent terms. And then you add in all the independent terms and you interact the snot out of everything. You just go, everything gets interacted with everything else. And then the last step, which usually is a little bit of work, can be a lot of bit of work, you take every single term you entered in step one. Those are your first and second order terms. And you interact them with every single term you entered in step two. Those are your zero order terms. And that is the end of the model building. And sometimes you get a decently small model. Sometimes it's a huge model. But that's where you begin. That's where we start our model building. Because at this point, we're allowing for every possible relationship between the dependent variable y and the x's. And that's our starting point. And the way that we're going to approach it, we're going to be called build downers. We build down. We start with this big old mess, this big complete second order model, and then we start testing different pieces of it. Okay? So that's the approach. We'll talk about testing a model in another video, another lecture coming up soon. So that's how we do it. 1, 2, 3. And the thinking part is here and here, where you work with the quantitative and the qualitative terms. This one, if you've done your work correctly in 1 and 2, you just interact everything. And so let's take a look at a couple examples in this video, and we'll see what you think. So let's go to the next slide here, and we'll look at this example. In your project that you're working for me, or I guess for me this semester, your project data has one quantitative, and we're talking about independent variables here. You have one quantitative independent variable, let's call it x1, and you have one qualitative variable with 2 levels. And we've defined them, or you should have defined them in your data set. When you do your multiple regression work, when you work with the qualitative variable, you should have defined them as either 0 or 1. 0 if this level, 1 if that level. And now initially you had 3 levels, and remember for the last project, I'm having you delete one of the levels and just work with 2. So you should have 50 observations. Okay? And so that's our data. Now let's go and take a look at how that works with our project. So let's start with the quantitative piece. In step 1, we need to take a look at this x1 term. Now how can we write that as a first or second order term? We do it right there. There's our step 1, right? The x1 and the x1 squared. That's how I enter the quantitative portion of the model. I have one quantitative variable. I put it as an x1. I put it in as an x1 squared. In the second step, I look at my qualitative variable and I put it in as x2. Now, because there's only one of them, that's the only way it goes in there. Again, we've had the conversation before. These are dummy variables. These are 0, 1s. It doesn't make sense to square the dummy variables. Okay, the qualitative variables only get entered in as themselves. And then look what I did in step 3. So step 1 is done here. Step 2 is here. And now in step 3, I take all the step 1 terms and interact them with all the step 2 terms. So the x1 from step 1 gets interacted with the x2. That's this guy right here. The x1 squared, this guy, also gets interacted, and that's what gives me this term. And I'm done. And so there were 2 terms entered there. There's 1 here, and then we actually multiply those 2 things. Because these 2 get interacted with this 1, there's going to be 2 terms entered here. There's a total of 5 regression terms. There's 2 variables and 5 terms. Sample size requirement in regression, multiply that by 10. Multiply the number of terms in your complete second order model by 10, and that'll tell you the sample size that you need. And so that's how we build the complete second order model. Now, in terms of the practical doing of this, in your data set, you're going to need a column of y's. Well, you probably already have that. You're going to need a column of x1s. You probably already have that. You have already collected that data. You're going to need a column of x2s. Again, you already have that. But you don't have the x1 squared typically. You don't have the x1, x2 interaction term. and you don't have the x1 squared x2 term. Now, what would you call this term? Well, it's definitely an interaction because you have two different variables being multiplied, but it's also a quadratic. There's a lot going on. There's a qualitative component here. That's the x2. There's a quantitative component. So everything we're doing, this x1 squared x2 has a piece of. That's the complete second order model for your project. That's the one you're going to work on in your multiple regression project. And so you're going to have to create those columns. I'll show you how to do it. Don't worry. All right, let's take a look at another example. Let's go to this guy. Initially, think about what you had. You had a single quantitative variable for your projects, again I'm talking, and you had 3 levels. And so now when we go to define our variables, we're going to need 2 different qualitative variables. And we've talked about this before, but we define x2 to be 1 if, let's say I'm working with 3 different models of vehicle. Let's say these are the Camaros. 0 if not. That's kind of ugly, but you get the idea. X3 would be, maybe one of my other levels was a Mustang. Comparing the price of vehicles, maybe I'm doing Camaros, Chargers, and Mustangs, and I'll say if not. And my third level maybe was a Dodge Charger. That would be when x2 and x3 are both equal to 0. So this is the data you initially started with. And then I told you, rather than look at your 3 levels for your multiple regression project, just knock it down to 2. But let's see what our complete second order model would have looked like here. So again, go through them. Step 1, what would you enter? Well, we still have just a single x. We have one quantitative x, so we'd enter x1 and we'd enter x1 squared. How about this guy? x2 and x3. I have 2 dummy variables, so I'm going to put in x2, I'm going to put in x3, but here's where it gets tricky. What about x2, x3? What about an interaction between them? And it's tricky because I can't give you a hard and fast rule. I can't say, oh yeah, always interact them, or oh no, don't interact them, never interact them, because it depends. And so let me show you the model, and I'll talk a little bit about it. There's your model. Step 1, step 2, step 3. In step 1, we're putting in x1 squared and x1 squared. I'm sorry, x1 and x1 squared. We talked about that. That one's pretty easy. That's what we did in the last example. But in step 2, it gets a little bit more challenging because we have x2 and x3. And then what's really challenging is this question. Do we interact x2 and x3? Now you can see in this example, I didn't. Why not? Because I can tell you this, in another example, I might. And here's how you figure it out. Think about what x2 and x3 represent in this case. x2 and x3 are the 2 dummy variables necessary to define the 3 levels of the model of vehicle. Camaro, Charger, and Mustang, or Camaro, Mustang, and Charger, if you want to think about it in that order. It doesn't really matter. So I need 2 dummy variables to define those. So if you think about the values of x2 and x3, can they ever be 1 at the same time? Can x2 be 1 and x3 be 1? No, they can't. And this will always be the case when you're looking at, and this is the way I'm going to say it, when you look at dummy variables that come from the same qualitative variable. Because those dummies are defined to just represent the different levels. If I had 6 different models of vehicle that I was working with, I'd have 5 dummy variables. And none of them could be 1 at the same time, because it's either 1 if this one, 0 if not, 1 if that one, 0 if not, 1 if that one, 0 if not. And so when the dummies come from the same qualitative variable, and you can see how I write it here, it's a qualitative variable with 3 levels defined by these 2 dummies, you're never going to interact them. But what if there was another qualitative variable? What if we're trying to predict the price of a car? What if x1 is mileage, and then I have the 3 models, and then I have another vehicle or another qualitative variable that is, say, x4, 1 if it's a convertible, 0 if not. Well, think about that. If I have another variable, x4, 1 if it's a convertible, 0 if not. Does a car being a convertible have anything to do with the price? Probably, yeah. Convertibles are more expensive. And so I would have, in step 1, I'd still have x1 and x1 squared because I'm dealing just with the quantitative. In step 2, though, I would have x2, I would have x3, I would also have an x4 term to represent my convertible or not variable. And now I would also be able to interact x2 with x4 and x3 with x4. And that would all be called step 2 because I'd be working with the qualitative dummies there. And so our rule is if the dummy variables come from the same qualitative variable, okay, if the dummies come from the same qualitative variable like x2 and x3 here, you cannot interact them. But if the dummies come from different qualitative variables, like if I had an x4, which I'm not really introducing, I'm just having a conversation with you. If there was an x4 that was the 1 if convertible, 0 if not, I can interact dummies that come from different qualitative variables. So in addition to putting an x4 in, I would also include an x2 and x4 and an x3 and x4. And so this step here would get a little bit bigger. That's why I say the thinking part is in step 1 and step 2, trying to figure out how do I include the quantitative terms, how do I include the qualitative terms, and then in step 3, which whatever you did here in step 1 and step 2, now you just go crazy. So we don't have x4 in this particular example. You can see the model would grow quite a bit. We don't have x4, so what I'm going to do in step 3 down here is I'm going to take x1 and interact it with x2. Yep, got that one. I'm going to interact x1 with x3. That one's over here. x1 squared with x2. x1 squared with x3. Got it. And so I have 8 terms in my complete second order model. And so now I got to make sure there's a column for each of these terms. So you end up with a column for y, and then these eight other columns. You end up with 9 columns. You take a look, there's 8 terms multiplied by 10. Sample size requirement is 80. Sample size requirement in regression is 10 times that biggest number in your complete second order model, and it's 8 terms in this case. So that's building the complete second order model, and all that is, folks, is that's your starting point. Now we're going to go and start testing the model. We want to test to see, is there anything in here that's useful? And we'll talk about it. There's going to be 3 different ways to test a model, but that's another video, another time, and until then, so long.